Okay, for number 7, I'm going to use Sage, Computer Algebra System. Um, and I think going back and forth between different applications show you some of the advantages. Again, I'm just using the software to help myself visualize. I know it's a fourth degree polynomial, get a general idea of shape. I go through the analysis in a blue area. I think you should read through that. But now I'm going to start talking about technology use. So I'm going to go to Sage. Let me just clear the screen. And, let me, start formally by resetting. X is a variable. A little more complicated than other software. F of x. F of x equals x to the fourth power plus 3x cubed. That's 3 star x, sorry about that. Minus 3x, 3 star x, keep making that mistake today, plus 1. Right, that's what f of x is. I'm going to plot PLOT. Now, the fact that you're learning software, when you do this, you may look at it and say, it's not the graph I wanted. And someone says, how do you know what the graph you want? Well, I want to just cut to the chase, and I bet there's a graph over here, 374. This is the graph I want. And what they're giving me just a small section of it. So what I want to do is I want to close this out, and I want to start playing around with it. And what I'm going to do is I'm going to go back to my Sage application, and we've done this before, xmin. And xmin, looking at the graph, I can say around minus 3. I can say xmax. Again, I'm looking at the graph. I'm going to say about 1.5. Let's say it's 2. All right? Now, granted, looking at it, you can say, I still don't see the graph that I'm providing over here. Well, I'm going to still play around with it. And what I'm going to do is, I'm going to go back to this graph over here and talk about xmin and xmax. But not only that, ymin, ymax. So ymin equals, I'm going to say minus 2, and ymax, I'm going to say, I don't know, about 4. All right, I'm getting a better picture. I want to point out the advantage of Grapher, though. It's not so much playing around with it. You can more easily manipulate the axes than you can with Sage. Sage is great software, though. Don't think it's something not worthwhile. But here, I'm kind of looking at it, and certainly looking at the graph. Again, I want to pull this on the side over here. 2 different graphs over here. Looking at the graph, I'm getting the same relative shape of it. All right. A local min here. It's also a global minimum. A local max here. A local min over here. I'm seeing 1, 2, 3, 4 roots. And the roots I'm seeing over here, and certainly Descartes rule of signs would help me a great deal over here about what the roots are. But here's the deal. I'm looking at it, and without doing too much fussing with it, I see 2 roots over here. I see a root there, and I see a root over here. I'm definitely see 4 real roots. All right, so that's basic idea. All right, basic idea. Let's go back over the problem now. And certainly when I put this down over here, I'm analyzing. All right, I'm not using discard rule sign, just intermediate value theorem, kind of like popping around what it is, and kind of understanding the sign of it, getting a general shape of it. And then I do want to point out, looking at it, I do see roots between minus 3 and minus 2. Let me go to the graph. That's right over here. Sign out, so I'm seeing one between minus 2 and minus 1. I'm seeing that over here. And I just by simple sign, I should see that. I'm not even using this cardinal sign. The problem, though, is I want to claim over here is that, you could go to Descartes rule of signs and maybe understand there's 2 roots of this over here. The problem is if you're just doing sign analysis, you get positive, positive, right? If you're doing 1 and 0, you may miss it. You may miss it. Right. Here's the deal, though. some understanding of numbers that you realize that when you go past the one, the fourth degree polynomial is going to take off. So you go backwards and you try to use fractions over here. And I think you'd arrive at that. I do talk about using other things like derivatives, about increasing, decreasing. And it's not a bad way to go about it, all right? There's many things you have at your disposal. Paper and pencil, your understanding of derivatives now, your understanding of the square rule of signs, upper bound, lower bounds of limits, Sturm's theorem. There's a lot of stuff you can go to. However, I don't see anything as being as powerful as a piece of software. Right? Software is really powerful. All right. So I think there's one more problem in the set, and I'm going to talk about going to a different application on this one over here. Okay. But there's still analysis down. The analysis is important. It's very important. Okay. Thank you.